The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kīlauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, and so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed, and we knew we were getting to the local community, and people were asking questions. So those were the best. I think I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well, and we got to a lot of people we wouldn't have normally gotten.
Hello everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont from the nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute. Happy New Year everyone, it's January 9th, 2025, our first update of the new year. And Kīlauea has put on quite a show over the last 2.5 weeks or so, conveniently during our break, of course not. So we'll start to recap what happened there and bring on a special guest today from the USGS to help us get back on track here. Just a little bit of what we have in store today. Dane, what else have we got to add to what we're going to talk about today?
Yeah, so we had a ton of great footage shared with us on Hawaii Tracker over the past 2.5 weeks. So we're going to provide a little highlight reel of some of the stuff that was shared with us there. And then Lou is going to go through some of his experiences from his perspective, because he was on top of this this eruption. So we wanted to pass it to him and see what he had to say about it to recap.
Yeah, awesome. And how have you been for the last couple of weeks?
I've been good to try and take some time off as much as can. You know, it didn't get off to the best start, but in that term, but we had a spectacular eruption, and we now had 3 phases completed and wondering about the 4th potential, if it is it or not.
Will it or won't it, right? That's the question that we will not be able to answer today, but that we'll be dancing all around, right?
Right.
So, all right. With all that said, shall we get going to our summary?
Yeah, if anybody's got any questions, we'll be doing the volcano update, the current situation, and the science up front. And then so if you got questions for that, drop them there. And then afterwards, it's going to be more loose and more, amazing shots and videos and stuff like that.
All right, awesome. Yeah, so thanks, Dane, and thanks, Lou, of course, in the back end, who'll be on a little later, for all the effort over the last couple of weeks. So let's try to catch up here, and let's switch our screens around, put everything in the right configuration for our summary. Well, everyone, this is our Hawaiian Volcano summary for January 9th, 2025. Kīlauea erupted at its summit over 12 days between December 23rd and January 3rd, with lava contained within the caldera, as shown on this map here. The initial phase of 3 phases flooded the whole crater floor all the way to the east, covering the September 2023 flows shown here in purple. But the later phases, 2nd and 3rd episodes of this eruption, were more contained to the southwest part of the crater floor, where the eruptive vents were located. So magma continues to feed into the volcano underground, as evidenced by the ground tilt. So let's bring that up for you guys here. Well, first let's show you guys, here it is. This is the tilt plot for much of the last month. So here we are at the right end of it with the volcano inflating at the summit, showing magmas coming to the volcano. But as you can see, the rate of inflation is lower than at some other times and some of the other pauses. So it remains to be seen whether the eruption will resume or not. See, here are the 3 phases plotted on the tilt graph, with the first episode lasting 14 hours, second episode lasting 15 hours, and the third episode lasting 8.5 days. As you can see, the 2 pauses we had were fairly short, less than 24 hours each, whereas we are now ongoing in the 6th day of pause since the last activity on the volcano. So that's how it looks like from the monitoring. The earthquakes have been low ever since the eruption began on the 23rd, with some slight variations that we'll examine in a bit. You can see the distribution of earthquakes over the last week, as shown on this map, are very scattered. You see a concentration underneath the summit of Kīlauea here. And you also see this south flank population as well, which usually indicates adjustment of the volcano's south flank to magma building in the summit and the rift zones, Upper East Rift and the Southwest Rift. The most recent large earthquake on this map was this one, it happened this morning, a south flank event showing adjustment of the volcano. So you have to wonder, as the volcano is in pause, how it's adjusting to the magma coming in underground and what that will lead to next. One thing that's useful to look at beyond the summit tilt, shown here in blue, is the Pu'o'o tilt on the Middle East Rift Zone, which just since that pause began has started to show a slight turnaround, a very, very slight inflation. So without knowing exactly what the cause of that is, we can say that the volcano is adjusting over a larger area than it was previously. But this is very small and very localized and still very brief so far. Here is the last year of distance across Kīlauea summit, where we saw the distance increasing from north to south. So the actual measurement getting larger. And it gets larger and larger and larger until it actually stretches out to break during eruption. Then we see some adjustments of the phases in here. And as the volcano essentially exhales its lava and in its most recent phase, you see the contraction of the summit caldera. And since then, a resumption of spreading. If we look on a rift zone, we don't see this effect yet. We in fact see contraction in the rift zone. So it seems like it's an overall adjustment of the volcano, and still our focus should be on the summit. That's the summary for Kīlauea. Mauna Loa is still quite quiet following its established post-eruption pattern, with these are the earthquakes over the last month, pretty scattered around the summit region with no concentrations there. Overall, the volcano continues to slowly rise as it fills within. And that's our Hawaiian volcano summary for this week. Okay, so we'll turn to the primary concern for our island residents at this point in time, which is the VOG, because we've had Kona winds, especially since Saturday, that have brought a lot of this volcanic emissions across populated areas of the island here. So as usual, we'll turn to the Manoa VMAP project here, and they offer a VOG forecast dashboard, which currently looks like this. We have emission rates from Kīlauea here, and a dispersion pattern based on the current weather conditions of where this VOG may be carried. So you can see it could be quite heavy, especially on the Kona side and in South Hawaii. But that's now that the trade winds have returned. Over the past few days, much of this blew to the north, as we'll see in our special interview coming up. To take another look at the current conditions here, I thought we could turn to Purple Air. This is a citizen science monitoring network where any one of us could buy some equipment and connect it to this network. And you can see here that we have most of our yellows over here on the Kona and South Kona side. So it does seem like there is still lingering effects of the VOG, especially there. Whereas today, it seems clearer in Hilo and Volcano area, perhaps partly due to the recent rainfall that's come through overnight. So that's the localized VOG dispersal. And I do like sometimes when we have these big pulses to turn to our windy.com SO2 layer. And there you see the extra red color from emissions here in Hawaii. But this might capture a little bit more of that northward plume that occurred over the last few days that was blown with the weather changing from the Kona direction. And on a global scale, it's not really visible because there's a lot of other SO2 sources you can see, especially in Africa and East Asia here, that are just adding to the swirl that travels across the globe here. But more localized, you can probably say that this patch in here is Kīlauea related and likely what was blowing downwind initially as well. So that's the hazard summary. It's really the VOG is the biggest concern right now. And it does look like it's improving given the changing weather here in the last day or so. Okay, so that's just the most current thing here. We will turn to monitoring next, and just to show the current USGS update from today, the eruption that began on Monday, December 23rd, has been paused since 8:40 p.m. on Friday, January 3rd, with glow persisting still, and otherwise no unusual activity along either rift zone. Very few earthquakes, and nothing else to really highlight right here at this moment in time. I think now is the moment that we will turn to our special interview with USGS Hawaiian Volcanoes Observatory geologist Katie Milliken, who Dan interviewed earlier today. So she is the expert on this now, and we'll turn to her to both summarize what happened during eruption to some degree, as well as catch us up on where we look now in our current outlook. So Dan, I'll pass it to you to manipulate that as you wish.
All right. We're joined today by Katie Mulligan from the USGS Hawaiian Volcano Observatory, who's been so kind to come on and give us a little summary of the most recent activity, the December 23rd eruption, and what's happened since then. Without further ado, Katie, thank you for joining us.
Thanks, Dane. Thanks for having me. I have a PowerPoint that I'd like to share, so let me get that up. Okay, can you see my slide?
Yes.
Okay, awesome. So yeah, we had an eruption at Kīlauea Summit from December 23rd to January 3rd. Right now, Kīlauea's status is still at alert level watch and aviation color code orange because we're still seeing some signs of unrest beneath the surface, perhaps indicating that the eruption might resume. And this is a screenshot of one of the webcam images that I grabbed this morning. So you can see a lot of that dark black material on the caldera floor is the new lava that was erupted during this recent eruption. And the vents in the left side of the image there, you can see are still degassing quite a bit. So we're still seeing a little small amount of tremor at the summit that's likely associated with that degassing. But right now, Kīlauea is not currently erupting. So before I talk about the holiday excitement, I just wanted to step back and show this plot of earthquake activity at the summit of Kīlauea over the past couple of years. And what I wanted to highlight in this slide is that prior to the recent Kīlauea summit eruptions and intrusions that we've been having, as well as the upper rift zone activity that we've had in the past year, we've had increasing amounts of earthquake activity in the weeks to months prior to the events. But if you look, so this plot is showing the number of earthquakes per week over the past couple of years. So time is on the x-axis there with the earthquakes per week on the y-axis. And if you look at the right side of the plot, which is the weeks and months right before this most recent eruption we had, you can see that we really didn't have that many earthquakes, much less than we had prior to other eruptions and intrusions at Kīlauea. So this recent eruption was different in that way.
Do you think right there you could hit that hide button on that little thing on the bottom on the graph, and then we can see the graph fully? Right.
There we go. Sorry about that. Yeah, so this plot again shows past couple of years, and those bars are showing the numbers of earthquakes per week in Kilauea's summit region.
You can really see how it ramps up.
Yeah, prior to a lot of the previous eruptions, but this one we were starting to see a bit of ramp up, but really didn't reach the level that it had for previous eruptions. So that night we did start to see elevated earthquake activity, really small earthquakes associated with magma moving to the surface about half an hour before the eruption began. So this time-lapse video is showing imagery from the B2 cam, which is located on the caldera floor, and it looks west. You can see it had a really good view of the vents opening up there. Quite a few vents opened up in that west part of the caldera, and then activity kind of centralized at a few vents there. Lava flows really rapidly covered a lot of the caldera floor of that down-drop block in Halema'uma'u area. So the eruption continued, and it had 3 different episodes, so it paused a couple of times. The first episode started 2:20 a.m. on December 23rd, and then had paused by the afternoon that day. So that episode just lasted about 14 hours. Resumed on December 24th at 8 a.m., went on for 15 hours, and paused on Christmas Day that morning. And then episode 3, the final episode, started on December 26th at about 8 a.m., and that episode continued for about 8.5 days. So that was the longest. The highest lava fountains were about 300 feet. You can see the photo on the left shows the tephra that was deposited downwind on the crater rim. So this is in a closed area of Hawaiʻi Volcanoes National Park on a portion of Crater Rim Drive that has been closed to the public since 2008. But you can see a lot of that tephra accumulated on the road there. It also built up, and so tephra is just a word for lava material that is ejected and travels through the air before it's deposited on the ground. And you can see in the bottom photo, the bottom right photo, that a cone of that tephra material kind of built up on the caldera floor and on the caldera wall around the main vent, main couple of vents that were active during this eruption. And the photo on the right, upper right, just shows that tephra cone. Even though the eruption has paused, we're still seeing quite a bit of gas degassing continuing at those vents. So this is another webcam video from this is the V1 cam, which is the live stream cam. And you're going to see the eruption start and lava flows quickly flood the caldera floor. The camera perspective is going to adjust a bunch because this is a pan tilt zoom camera, which is really neat. So it allows us to change the perspective remotely. And, you know, we're during that time frame when it was changing a bunch, we're trying to find the best angle to look at the vents. But what I want to point out here, this video actually captures the entirety of episode 1 on December 23rd. And right here, lava flows are moving from the right to the left in this video, which is they're moving from that west vent area to the east across the caldera floor. At some point in the afternoon, they're going to switch and start to flow the opposite direction. So what we saw in those pause events, there it goes, is that we were seeing drainback. And that's actually kind of been commonly observed for high fountaining eruptions such as Kīlauea Iki, where you get lava draining back into the vent when the eruption slows and eventually maybe effusion pauses. And the thinking here was that some of that lava was really degassed and more dense. So as it drained back into the vent, it maybe formed a plug over the vent. And then eventually that plug was cleared after enough pressure had rebuilt and the eruption resumed in those subsequent episodes 2 and 3. So in total, the eruption, this map is from January 2nd, sorry. The eruption covered 673 acres of the caldera floor with new lava, and those are shown in the pink and red colors there. The purple is the September 2023 eruption within the summit. So you can see that a lot of that material got covered with lava, this more recent lava. About 4 billion gallons was erupted. And for comparison, I just have statistics from the Nepal eruption from September 2024. So that eruption was about half the duration, but it erupted less than a quarter of the volume of this eruption and covered much less area. So interesting comparison there. That Nepal eruption, of course, happened out on the Middle East rift zone, so different area of Kīlauea.
That 40 feet that we see there, the 40 foot, is that the average depth of the new layer of lava across the lava lake?
Yep. Yeah. So about 40 feet of new lava was added to the floor of the caldera during this recent eruption. Since the eruption ended, some of that, the caldera floor has subsided a bit. So we've seen that with the continuous laser rangefinder. So that laser rangefinder is just pointed at one location on the caldera floor, but we're seeing that, yeah, it's subsiding a bit since the eruption ended. So that's probably likely due to some continued degassing.
Yeah, one thing we see or get commented on is like, wow, the floor looks so uniform and so flat. Like, there's a lot of variation out there too. Like, yeah, there's definitely when you're down there. I've only been down to the caldera floor once or twice, but there is a surprising amount of topography, and even on that. So in this map, the area labeled the down drop block, it looks pretty flat from this perspective, from this digital elevation model. But when you're down there, there's just really quite a lot of topography. So the scale is hard to imagine here. But yeah, really cool. So. Yeah, and then I just wanted to note that the sulfur dioxide emissions degassing is continuing. We've recently had Kona winds. So normally we have our trade winds coming from the northeast, and then they take the gas emissions from Kīlauea, take them southwest, and they wrap around the island, and they sometimes get trapped around Kona. But recently we've had Kona winds, which means that the winds have been coming from the opposite direction. So we've been having relatively some fog in Hilo and around the island. And I got this screen capture. Let's see if I can get it to play. Here we go. Yeah, this is from the VOG information dashboard. And you can see that the highlighted orange colors are kind of showing that VOG over the past few days when it's been Kona wind conditions. But we're supposed to have, starting today, those trade winds return, and the VOG's going to be taking more our traditional kind of southwest directions. And related to that is that we haven't had a good emission rate estimate for a few days because of the trade wind conditions. So that model is using an estimated value of 30,000 tons per day. It's likely that the emissions are actually lower than that, and we hope to have a better estimate soon once the wind conditions are favorable. I just came to the realization that the wind conditions, especially with how you have to measure the SO2, would play such a factor in, because again, where would you measure from that when it's in that direction? Where,
And most of our the instrumentation is located downwind for like a typical trade wind condition. So most of our instrumentation southwest of the summit, but in Kona winds and also the winds haven't been very strong. So a lot of the gas has just been kind of wafting up to higher elevations, which makes it very hard to measure, because to measure, you need to get underneath the plume. So you need to have stronger wind conditions.
Oh, good to know.
Yeah. And then, so that's kind of the eruption update. I also wanted to note that, yeah, we are seeing continued inflation at the summit. We've only had about 7 microradians of inflation since the eruption ended. The most recent episode ended. The summit deflated about 28 microradians, so it hasn't recuperated much of that loss in terms of ground deformation. So we're continuing to monitor and see what comes in the next days. There is glow from the vent, continuing glow. So the screenshot in the upper right is from last night, and continued degassing, as I mentioned. So there's potential that the eruption could resume. We're going to continue to see how the inflation rate continues. As you can see, since the eruption ended, it's been a little bit variable. So there's been periods where it's at a higher rate, and then maybe it decreases. And so it really just remains to be seen what the summit does in terms of the inflation, and that will really help determine whether or not the eruption might resume.
Well, awesome presentation. I see you have a little bit of something to teaser there at the end.
Yeah, I just wanted to note that it's Volcano Awareness Month, so we have a number of events around the island to promote volcano awareness. A lot of these are in Hawaii'i Volcanoes National Park, but we also have events in Kona, Kealakekua, around the island, Hilo, and we are also doing an art and poetry contest. So if folks are interested, they can email Ask HVO, and I'll send them more information. And we're really looking forward to getting entries from folks around the island.
All right. I was going to ask you some questions, but you really were able to touch upon just about all of them during your presentation, which is awesome.
Nice.
The one I wanted to ask you, I do have here, is about just the last little bit. We were looking at the S2, or still the glow at night coming out of the vent. And for people not familiar, what do you think, what is the cause of that? Is that more the gas keeping the chimney hot, or the lava below reflecting and creating off of the gas, or what's the thought on why it's still, we're paused, but it glows at night, essentially?
Yeah, that's a really good question. And I think that tomorrow we have an overflight planned for the morning, which will hopefully help to answer that question. In past eruptions, we've seen that the vent remains open. So there's still molten material visible in the vent, even though there's not actually molten material like flowing out on the surface. And so that could be contributing to the glow. If the gases are hard enough, they might be glowing. So we should find out more tomorrow.
Awesome. And one other one. So we're seeing the episodes now. We're talking about episodes and pauses. And I wanted to just highlight maybe what is a pause, when does an episode, and how is that different from a new eruption, essentially?
Yes, those are good questions that we sometimes debate internally as well. But I think it has to do with whether or not eruptive activity comes from the same vent, or the same general area. That is usually considered the same eruption. If it's popping out in an entirely new area, that's considered generally a new eruption. So that the summit versus one of the rift zones, those are very different geographic areas, and it involves some kind of transport of material beneath the surface. So that would be considered a new eruption. That's at least, I think, HVO's philosophy. I know that other organizations approach things differently. So the Global Volcanism Program, the Smithsonian Institution's Global Volcanism Program, they use a time definition. So if it's within 3 months, no matter the location on the volcano, they consider it the same eruption. So it's really interesting because if you check their website, they list Kīlauea as being in one eruptive phase from 1983 to 2018. Even though we at HVO consider there have been, several distinct eruptions within that time frame. So, at the summit from 2008 to 2018, and then at Pu'uo'o vent on the Middle East Rift Zone from 83 to 2018, and then of course the separate Lower East Rift Zone eruption in 2018. Those to us are very distinct, and they're of course related in some ways, but the Smithsonian Institution has them as kind of one phase. So yeah, it just depends on the organization and how they're defining it.
Awesome. Well, thank you for coming and sitting down with us. I'm sure everybody here is going to enjoy that. And thanks again. Hopefully we can do this again in the future. And
Yeah,
until
sure
next
thing.
time,
Thanks.
yeah, we'll see what
Yeah.
the future holds. Maybe we're in a pause. Maybe it's into the eruption. Don't know yet. Time will tell. So thank you
Yeah.
again, and have a
Thank
good
you,
day.
Dane.
All
You
right.
too.
Bye.
Bye.
All right. So
All right,
yeah, that
awesome.
was Katie. Yeah, go ahead.
Yeah, no, go ahead. Yeah, I did a good job there. Great to have Katie, who has been part of the whole team watching this the last 2 weeks while we've been off, catching us up
Yeah.
here.
Yeah, really good to have somebody from USGS HVO sit down with us and go over this eruption as a recap and the graphics and everything that she shared there. I'm sure the volcano awareness nut helps with having prepared graphics, but that is really cool. Like, I really appreciated this whole thing. So I think with that, you want to get into the mid-roll?
I still got a bunch of other stuff.
Sorry, go for it. Sorry. Sorry,
Yeah,
skipped
and I was
ahead.
also going to say that we maybe following up on Katie's presentation and your comment there, there is going to be a talk tomorrow night in Volcano, which we hope to live stream for you guys. Or if not, we'll record and rebroadcast depending on how it goes. But likely we'll hear more and have a fuller version of that presentation to share with you guys tomorrow. Yeah, I thought what we could do is just run through some of the other monitoring data that Katie has not mentioned. I'll try not to duplicate too much, and we'll leave some to examine next week as well. But we do have our lineup of graphs here. We have a graph of the last week of summit crater elevation, which, if you notice, has a lot of noise. These little blue ticks all through here are places where the laser rangefinder hit some other piece of cloud, perhaps, and that's changed the scale here. So the real data is this line here in the middle, which you see was actually rising and falling a little bit, but you can't see so much over the last week. We'll see the same kind of pattern with the noise over the last month here. So over the last week, we see earthquakes have been between 30 and this one day 60 earthquakes per day. So this is closer to the background level. If we look at the red line, you see that there is a little bit of more energy in earthquakes released just today. That was at magnitude 3-ish on the south flank that we referred to in the summary. The East Rift tilt over the last week is a little more zoomed in for us to compare. The blue line is a summit. The green line is the rift zone at Pu'o'o. And it's hard to tell, and you can see the scale is very small. That's the first thing I mentioned here. We're looking at, this is 0, this is 1 microradian. So all these little wiggles on the green line at the rift zone are all just a fraction of a microradian. So very, very small amounts. Hard to really say anything meaningful off of that. But when we've seen it decreasing fairly steadily for a while throughout most of the eruption, we see here when the summit eruption ends, the summit starts to inflate with those varying rates as Katie described. We see here that after a little while, maybe most convincingly somewhere in here, we see the green line start to just creep upwards a slight amount here and come up a little bit more. And as I said earlier, it's not convincing to me that this is caused necessarily by magma near Pu'o'o, but certainly we can see that the effects of the volcano's adjustments are outside of just the summit area when we look at some of the tilt plots here. And as well as the earthquakes, right? Here is the earthquakes depth versus time. This yellow dot here is that south flank earthquake today. Everything else is that background around the summit and south flank here, with a little bit of background by Pahala as well, still ongoing, as has been the case for several years now. So there's the map again. There's our south flank event right there, just south of the recent eruption site. And so right over here is Nepal crater on the Middle East Rift. This is the place where the lava most recently erupted on the East Rift. And just seaward of that, we have this magnitude 3 earthquake occurring today on the south flank. So we did see that prior to this whole eruption, the build up to this event. Prior to that, we saw magma filling the summit region and a little bit of the upper southwest rift and the upper east rift all the way to the eruption site, that whole region in there. And about a week or so prior to the summit eruption, we saw that was cut off and the earthquakes focused almost entirely on the summit. So we're not seeing events here on a Middle East Rift and Upper East Rift connector yet. but you'd imagine that someday there would be some reestablishment of that pathway. And when that happens, you'd expect to see more south flank motion as well. So not quite clear exactly what's going on there, but we can say that as a result of this continuing influx of magma to the volcano, that it's continuing to adjust however it can, right? And as we saw most recently, the easiest way to adjust was by erupting out of the summit. So for now, that's still the default until we see evidence of something else, right? And the caveat that this could be the first baby step towards that. Maybe we'll have to wait and see. And cross-section earthquake. And here is the last month of elevations. And so you see a little bit more detail because there's still some noise of stray data points here and there. But eruption begins on the 23rd. So if I zoom it in, and we'll do the best we can with what we have here today, you see there was a surge of lava that made the crater a little bit deeper, and then we had drainback, so it went back in, and we almost resumed close to the original elevation. The second pulse comes here, and we see an increase, and that lasts a bit longer, and we don't see quite the same drop in elevation following that drainback. When we do have this third phase beginning in here, let's see, I think there's a second phase might have been actually in here, right? And the third phase beginning here, we do see that beginning right around New Year's Eve, somewhere in there. We see this increasing depth of the crater, has some little variations here as well. You see this, since eruption was over on a third, this settling and perhaps degassing driven loss in elevation that Kitty was referring to as well. And so they mention, and this might be a good point to come back to our daily update here, and note that the USGS states summit lavas are 50% or more bubbles. And even though there has been no visible flow of lava back into the vents during this ongoing pause, there is a gradual drop in lava level that they believe is likely due to loss of gas bubbles. Yeah, or possibly very slow leaking of lava into the vents beneath the surface crust on the crater floor. So that's really the point to pull out here. And coming back to this plot, and in that context, this is not so surprising here. There may be more detail to pull out as well, but for now, that's sufficient, I believe. So over the last month, here are earthquake counts built up to the eruption right there. It was certainly the highest earthquake count in the last month, even though, as Katie mentioned, the overall pattern for this eruption was not as many earthquakes in advance of the actual breakout. So maybe we see a little resurgence here coming up off of the background since eruption ended on the 3rd. But you see it's very, very slight, and maybe it's one of the reasons for this most recent south flank event too. So you can see the adjustment with slightly increased earthquakes, but still fairly low overall. Okay, we talked about the tilt here on the rift zones. Over the last month, it's much more subtle. There is our summit reinflation, and maybe if there's a rift one, it would be in here. But I'm still adding maybe because the scale is so small, and it seems to be in question for me still. Okay, so we look at other tilt meters. This is a summit at Sand Hill, and this is a station that we've in the past used to show both the Magma area inflating as well as the South Caldera area inflating. So it looks like it's a little bit more so on the summit than in the South Caldera, which once again supports our summit focus here. Okay, let's scroll past some of this to just show our earthquake counts for the last year. This is a little redundant with the 2-year graph we saw from the USGS, so we'll move on from that. And maybe now we can look in more detail at how that corresponds to the GPS. So there is our intrusion at the end of January into the South Caldera Southwest Rift that caused a contraction of the summit distance. Here we have intrusions in June, an eruption in June. June and July, was it? Yeah. Yep. And then we have, looks like another intrusion here on the East Rift that was in July. And we have our September, I'm sorry, the June eruption, the September eruption here on the East Rift. And there's so many eruptions that I keep track of. It's hard to come back to it and keep them all straight, right? This most recent one makes it, well, so the first one will start in December 2020. If we go to December 2024, that was 9 eruptions in that about 4-year period there. So forgive me for getting them mixed up here. All right, so then since then we've had that build up and wondering, we'll go back to the East Rift, there's a Southwest Rift over, and we saw finally right around in here that concentration of earthquakes at the summit and lack of them on the East Rift. Then we see this big stretching right here of the summit length. So we got as big as possible right there, that stretching right there. And likely when we have that first pulse of eruption, then it sags a bit, but it didn't last as long, so it continues stretching, sags, continues, and then finally here's this longest third episode that does most of the work. And since then, over the last 6 days or so, you can see that we've actually resumed this trend, right? So you can see magma still coming in, the crater is now stretching again, has not recovered to where it was before the eruption, both in distance and in tilt. But that shows you where we are now in this phase, right? It's not evident that this is about to resume quite yet, but it's also not evident that it's over. There's nothing really conclusive to plot out a GPS here. And along the same lines, at Pu'u'o, even though we see quite a lot of these adjustments, right? This was our big pulse with the eruption that occurred in September, intrusion coming into the eruption in September. And a lot of smaller adjustments since then. So within the context of this broad range, it's hard to say that this little decrease right in here means anything, but if anything, the trend has been one of contraction within this noise here. And we'll just wait to see how it adjusts and what shows up in the graphs moving forward. So here over the last 5 years, our earthquake counts, and it looks like since we're just in the beginning of this month, that's this lowest little bar here on the right. But you can see that the last 3 months of 2024 were low up until that eruption, were lower than the previous buildup or the previous eruptions over the year. And that's how it looks over the past 5 years, right? And so lots of eruptions. There's a 2020, there's 1, 2, is that 3 in there? 3, yeah, 4. We have Mauna Loa coming in also back in here. Well, I won't try to count the rest of them right now, right? But the key thing in Pu'u'o was that you see that prior to that 2024 episode, the line length across the East Rift had been contracting for a long time. And since that East Rift intrusion eruption pairing, we've seen more variation at Pu'u'o. And so that's why we're keeping a closer eye on it now and maybe over scrutinizing some of those little tilt wiggles. So closer in at Pu'u'o, here's what the tilt plot looks like. And we've looked at this green line showing inflation at the reservoir to the west by Makapui, Nepal area, and the blue line closer to the rift zone. And so this shows you where the signal is actually coming from and the scale. It looks like you're looking at less than 1 microradian, and it's focused south of Pu'u'o on the rift zone itself right now. So we'll wait and see what happens with that. We've seen little wiggles like this before, which were in the end not magma related. So it's still quite possible that this has nothing to do with magma. We'll have to wait and see. The timing is a little suspicious, right? Further down the rift at Jonica, you don't see anything different occurring over this phase, right? You mostly see the daily variations, and there's no other indication of increased threat to people on a lower East Rift. So the rest easy for now. There is one INSAR image to share. This comes from the Mounts project. This is captured on the 29th for the previous 12 days, and it's showing where the dike came in. So we saw this from the cameras already, but it's always nice to see this data. You see this butterfly pattern with one wing over here and a second wing over here. And usually the body of that butterfly is where that dike comes up. So more or less in there is that orientation. And that's what we saw from the vents on the crater wall and cutting across the crater floor in that first time lapse of the B2 camera USGS showed. Then all those inner vents drowned, died off, and activity focused on primarily 2 vents here on the southwest part of the crater. So that's the extra monitoring information we can add here. There is a little bit more to layer on if we add the volcano watches. Let's just do the last 2 weeks and not this week here. So there was one that talked about Kīlauea summit erupting, beginning all of that. And this is where they first mentioned the drainback events and how they were dramatic during a Kīlauea eruption in 1959. The idea being as the gas escapes from the lava is then flat, right? Like a flat soda pop. And then it's actually denser, right? If you imagine 50% gas and you take away all the gas and you have only the heavy stuff left, then that stuff can ooze its way back to the lowest possible spot and then act as a block until an equivalent force can push it back out again. And that's what they believe was happening during the pauses, was that pressure was building up enough to then flush out the drain back plug to resume the eruption. Right, so that makes sense to see. So that's the first volcano watch from a couple weeks ago, and then the one from last week, Happy New Year Hawaiian style. They have here this tilt plot, and marked on here are these periods of drain back, while the eruption was at that point still ongoing on December 2nd, one day before it ended, or paused perhaps. Yeah, so it's in that context that if we look at the graph shown by the USGS, we've had this longest pause now, and it does not seem like we're dealing with the same kind of drain back mechanism for this particular pause. Maybe so. Maybe you could argue, well, this was the longest lasting phase, put out a bunch more lava, and in that case, maybe there's a bigger volume of plug. That could be true, and we do see that there is still gas being released from the vents, showing that it's leaving the lava or magma underground in that nearby area still, right? So we're still in this period of uncertainty now as to what that really will lead to. All right, so I did want to show this plot. This is actually volume of lava erupted from Kīlauea in 1959. And so this is not exactly the same as a tilt. They did have tilt measurements then, but not instantaneous and continuously over the entire period. So you don't see quite the same nuance here, right? And what you see is there were, in the case of Kīlauea, 17 eruptive phases over a little bit more than a month. The first one in that case lasted the longest, had the longest pause. Then you had a second short one, and these little dashed lines in here represent the drain back phases, right? And actually what happened was the vent that was erupting built extra tall here in this fourth phase right here, such that when lava was draining back the next time, it drained to a lower level, and eventually the crater floor ended up thickening because of that. So I only bring this up to show some of the things that might be happening around our eruption now. We can dive into comparisons more so in the future. One thing that USGS was pointing out was a little bit unusual is that with our continual tilt monitoring, during the drain back, we were seeing inflation, right, which is counterintuitive to what you'd expect if the eruption was actually over and lava was going back in. But what you're seeing is that the drain back is paired with something pressurizing from below at the same time. It's not just a one-way flow back, right? So maybe not the best way to explain that, but my best effort today here, and that's the two drain back phases and how that's different from what we're seeing right now, right? We're not seeing this inflation, this more rapid inflationary pulse that you'd expect to be drained back with what's happening over the last 6 days. So that's the volcano watch. I thought we could, let's see here. What is next on my lineup? All right, the earthquakes. We need to show you guys the earthquakes. So here is earthquakes for the last 2 weeks across the volcano. And here you see that summit eruption site, the East Rift eruption site, the Southwest eruption site from last year. And for the last 2 weeks, not a whole lot of earthquakes. Some around the summit, a couple here clustered in the Upper East Rift connector. And the biggest one we have is this 3.1 that just occurred at 8:30 this morning about 5 miles down, 3.1 right there. You can see just seaward of the recent eruption site. And if I come out to, let's zoom it out to the entire island, and you see that we're at background levels across the board, right? And one interesting thing is that even Pahala's zone seems to be a little bit slowed down in the last month with Kīlauea releasing its pressure here. So not a lot to show there, but that is the current picture. And yeah, we'll move on from there. We'll touch on some of the observations that we have and focusing a little bit more to start here on a current. What does it look like right now? Here is the last 24 hours from the KW camera at the summit, showing a little bit of this weather coming through. You can see areas of degassing still. You see a little bit of glow from this vent at night way over here. And everything else is, at least in this most recent 24 hours, dark on the crater floor there. It's a current view from above, and there is also the S2 camera that was redeployed to look at the vents more closely. And so here you have a better view of exactly how those vents are glowing in more detail and more zoomed in here. So interesting to note there, and from what Katie described there, right, all this brown material is the tephra that landed on a crater wall during its eruption. Whatever landed on a crater wall was able to stick there and leave this blanket. And we saw that up on the upper road way up here, material was falling all the way up there as well. So you can imagine it wasn't just falling right there. It's just, this is where the slope can actually collect it. And you probably have a little bit of that blanket across all this crater all the way up. If you saw that whole field of tephra on a road that we saw in a photograph earlier up here. So yeah, those are the two most recent webcams. There is an image release from a couple of days ago showing the eruption remaining paused. So let's see if I can get this to just play right in here for us, maybe. So degassing quite a bit. As USGS mentioned, they're planning overflight tomorrow to look in there and see if they see any lava through the open conduit, or if perhaps, as Dane suggested, maybe it's just the hot gas still escaping and it's like a glowing chimney, so to speak. Right? So, but this closer zoomed in view, only the tephra across the crater wall there, you see some of these cracks, right, where it's slumping and sliding down. We see similar things on Pu'upua'i, which is the cone right above Kilauea Iki, when it was erupting as well. It was landing much higher on a rim, but a similar kind of slumping feature there of the tephra against the caldera wall. And you also see lots of these small little islets, which are pieces of these cones, which then have slid into the lava flow over the last 2 weeks or so, right, as it built up. So yeah, they do note that the vent was quiet. They've been out there photographing and measuring. And one interesting thing to note here is that they note the south cone height was measured at 118 feet, 36 meters, whereas a north cone was measured at 23 meters, 75 feet high. And so if you're wondering about the height of those, right, that's 120 feet, that's a 12-story building. And that's 75 feet. That's about an 8-story building right next to it there. And there's nothing really to compare. No tree, no person, no cars. Right, these are really massive, massive features in a huge, huge area that got covered by lava, as pointed out on that map earlier, right? More than 200 acres covered. And this one is cool. This reminds me of trying to put a golf ball and trying to read where the ball is going to go and which way is it going to roll. And what you're seeing is these tracks of rocks that have fallen off the crater wall and slid down this tephra and then rolled down towards the lava lake, as there continues to be vibration and tremor from the gas escaping. There were earthquakes still occurring nearby, and all the contraction and settling still occurring there. So something that might be seen if you're up there, some of the rock falls and those paths down the tephra. And I think one last image from that set here, just showing all the little small islands of solidified crust that are visible, pockmarking that crater floor, especially in this southwest section over here. That's the current release. I thought we also should come through some of these time-lapse images. So let me start off here. This is the thermal camera, and just the first pass through this. That first phase, there's a drainback in the first phase. You see overturning of the lava lake. The second phase comes in. It doesn't flood quite as far as the first phase, but gets pretty far. It drains back also. Crust overturns. The third phase begins more quietly, more localized before it ramps up with increased pressure. Maybe the plug is still getting cleared out, and once it's cleared out, then you can have this larger effusion of lava, and it starts building out. But because it's concentrated in the southwest section, it actually builds this raised area, almost like a perched pond area, but this whole southwest part, which then starts spilling over into other parts of the crater floor, allows big sheets to move and take big chunks of crust off to the side, as you see right there. You see not quite reaching as far as before, but still making a large part of the caldera floor, the inner caldera floor covered. And there, since then, the final overturns and then the cooling and degassing that we've seen in the last 3 days here. So that was just a quick run through the F1 camera. We can come back through and examine more details in the future, I believe. But just to show you another view of what that eruption looked like thermally. I always like to pair the thermal camera with the visible camera. So let's put this back to the start here. KW camera, there's that initial flood of lava. It makes it all the way onto the downdrop block around that September 2023 eruption site, all through here. You see the second pulse leaves a little bit of a high spot in the middle here, but really everything has been covered in lava. Here comes the third pulse, bottom right corner of the screen. And now you can maybe start seeing how it's going to start building this perched area right through here. And then when we start seeing overflows, it starts hitting rivers off of those edges. So contained here within the southwest part mostly, but then as this eruption ramps up, here's New Year's Day, you can see it makes this renewed push to the north from that southwest part and actually moves quite a bit of this crust. And this suggests that there's quite a bit of fluid lava underneath this whole area to allow that whole upper part to move, right? So it's able to inject and mobilize that area more so. And since the 5th, it's been dark and quiet, except for that one little corner, as we mentioned before. So that's a KW. The S2 camera, which shows more of this vents building up and collapsing. We'll take a first pass at that also. You see here some extra little vents off the side from the initial fissure that don't reactivate initially here. That's our north vent, and that's our south vent right there. The camera does shift a few times, so slightly different position there, but you see they're both active, and the south vent usually more active than the north vent, leading to a larger cone and larger outflows. You see some chunks of cone floating away right there. There's some more. Similar processes as we've seen in all our other summit eruptions, but it's all kind of coming together one more time here for us. And here we are in this degassing phase most recently. So one thing I wanted to point out that's a little interesting, and we'll dig at this more in the future, we'll come to the B2 camera. And this now, I've just clipped it between New Year's Day and a couple of days later, right? So this is when eruptions beginning to end. So way off here are the vents, south vent and north vent over there and there. The lava's coming across the crater floor all the way around. There's been a big flow push that comes through here with a little channelized middle right through here. And so I've sped this up a lot, and I'm just going to rock it back and forth. So what I'm trying to show you here is that for the first time, we actually saw evidence of the crater floor lifting here. And so I hope this makes it more clear. It's something that I had to convince myself because lava flows themselves can actually inflate, right? And so are we seeing the whole crater floor rising together, or some parts a little different? There are some different things. There's a little breakout right in here, you see happening, right? I'm wondering, when I look at this more fluid part of the channel, it seems to be wiggling a little bit more, but I see all the way from back in here, before moving all the way to here, more or less together, right? While the fountains are still going on the first, second, and third here, right? So as this eruption is coming to an end, we're seeing the crater floor beginning to bulge for the first time. And that makes me wonder, like, maybe something changed underground, right? And maybe that's why we saw the eruption actually come to an end. Not only do we have this natural process of the drainback and the fountaining, but if suddenly lava can go somewhere else and find somewhere else to fill underground, now you have more room for it to distribute all that pressure between. And that's really the situation we had coming up to the eruption, where we blocked off the east rift, everything focused on the summit. The dike came up, everything focused on the southwest part of the crater floor. All the changes in elevation seem to have been prior to this from the lava flowing out on the crater floor, filling it up, then draining back, then filling it up and draining back until maybe this very last phase right in here, as far as I can tell from this fairly quick examination, right? But something else is going on here that we'll dig into more in the future. And we know that USGS mentioned the rangefinder that measures the elevation is only focused on one part of the crater floor, likely in here, since they're talking about how much it's sagged since then, which is in the order of, I want to say 15 feet or so, 15, 20 feet. So leaving 25 feet left after everything is said and done in that area. But beyond that, you can see the crater floor is moving differently at different parts and at different times. And so there's more to the story to come we'll dig at in the future. And one last one here, I just thought I would play a little bit of the last phase of this V1, the live camera, to show these little islets forming. You see lava spatters landing on this while it's actually next to the vent, but floating in the lake, and then it eventually drifts away. You can see the actual cone growing and collapsing. Here you see that again as well. The shape's changing. So that's how you have so much of this tephra islets ending up covering the crater floor, as you see here. Last night aglow on the 4th, and then resumed to the vents. So that's the first part of Kīlauea here. Just very quickly, I'll mention Mauna Loa is not doing anything unusual. Everything is as expected there. Tilt is normal. The earthquakes are low. It's very much in that post-eruption pattern that we've seen since about 2 years ago now. So on a grand scale of things, looking at the 5-year earthquake rates on Mauna Loa, here we are still quite low compared to everything prior to November 2022. And all right, now we can shift gears a bit, Dane. I'll pass it back to you.
All right. Well, thank you, Phil. And we do have one question in the chat if you want to go ahead and take that before we shift over.
Yeah.
Question is from Shaka Brand, is the weight of all this new lava going to lead to another collapse of the caldera in the future?
Well, good question. I would think no, right? For one, the lava that's coming out is very, very gassy, so it's actually much frothier and less dense than a lot of the other stuff. Usually, if you're looking at the densest lava rocks, it's the results. It's the magma that's cooled underground, deep enough that it's not formed of bubbles, right? Things like dikes or sills or other kinds of intrusions like that. And along those lines, it's removing that degas lava from below that really does the trick for causing the caldera to collapse. It's more so taking away the support from below that causes collapse rather than weighing it down from above, right? If that makes sense. So this volcano is thought to have had a summit. Well, we look at the caldera today, and it actually slopes upwards on the walls that are cut into, right? So at some point before the most recent large collapse, we call it Powers collapse. We think it was maybe in the 1500s, somewhere in there. The slopes of the volcano actually rose another 100 feet higher than the current rim today. So it can actually get quite a bit taller without having a collapse. The collapses are more from pulling out the weight, the support from beneath. But good question, and good to have a chance to discuss that.
We did have one more come through from Obi-san, who asks, so when the first episode started and the fish are across the floor, did that come up through the other lava under the floor or not mixed with it? I haven't seen it.
Yeah, it's a great question. Yeah, we know the USGS has collected samples. I don't think I've seen the chemistry come back from them yet, right? And then there's also the question of which samples could they collect, right? Because what you're asking at, Obi-san, is a great thing that I'm sure even they would like to know, is how did the chemistry change over time of the eruption? And so they maybe were able to collect, let's say, tephra samples that landed up on an upper rim up here, maybe every day or every couple days. And maybe by analyzing those, you can try to get at some trend, right? And so that might give you some idea, but you'll have the risk of being all the way on the side. Maybe you're not cutting through the middle of this lava lake and some of the old lava as much. You have to cut through it down, deeper down than the actual lava lake we have here. So the fissures that came up through the middle of the lava on the crater floor, probably not something you can sample, especially not to catch the first couple hours eruption when you would have had that mixing fingerprint embedded in it. So we do know from Kīlauea's cooling and how they drilled the lava lake that 400-foot depth of lava stayed partially liquid for 36 years. And since we on Kīlauea have a much deeper, thicker funnel of lava, I think there certainly was still liquid lava in there. And without having any data to support it, it seems very, very likely that that fissure coming up through there probably did mix and flush out some of the older stuff. But how much and to what degree, that's really where we have to stop, and you can't really say anything about that. But it does seem likely that it did come up and mix through it. And yeah, good things to think about and imagine. And maybe that's got something to do with why those fissures on the main crater floor did not persist, but rather the one that was on the caldera wall, which did not have that obstruction, was the one that became the longest lasting. Yeah, and even maybe when it came up and through, that one was the one that was the biggest, the fastest. So maybe that was something that was true immediately. Like when lava was coming up, it was easier to come up, not through the goo, but through older, harder, brittle rock that you actually could crack and break and move up and through more easily, right? Rather than trying to force your way through goo and have a consistent, established path that can be sustained. Yeah, great things to discuss and think about. And yeah, that's just my thoughts on that.
Yeah. One more came through. We'll do this one last one. Are you kidding ass? Is it normal for earthquake activity to dramatically decrease when Kīlauea is erupting? I noticed a few days with little to no earthquake activity during the eruption.
Yes, yeah. Great question. And yes, exactly. It is normal and expected for that to happen. And it's happened every one of these last 9 eruptions in the last 4 years. Yeah, every single time.
All right. Well, thank you, Phil. And with that, I think we will pivot over and get Lou in here and go through some of the community stuff and head out into the second segment. All right. Thank you, Phil. Hey, Lou.
Hello.
Welcome. How you doing?
I'm good. I'm just still trying to absorb all that.
All right.
There's a lot of information.
Well,
Where are we starting tonight?
Community corner.
Let's start the community corner. All right.
Yes,
we can do
sir.
that. There we go. Well, Happy New Year to everybody. First of all, thank you for joining us all last year as well as this year as we start off. And let's go up to the park. As we've just been covering, there's a shot of the recent eruption. And traffic has slowed down because the eruption has slowed down up there, but construction is still going on. You can see that it says at the bottom, the Kīlauea eruption that began on 12/23 has paused, but there is still a lot of interest in it. So the construction mixed with the tours and the visitors, please go slow up there. Check out that nice shot from Janice Way from the National Park Service. She takes some amazing photos. All the roads are open. They may have some cones. When Dane and I went up there on Tuesday, the entrance of the park was coned off. They have a detour going around, so just go slow. And I got a shot while we were up there at the summit. The guys working, I don't know what they were doing, but that's where the Jagger building was at right there. The Kīlauea Visitor Center restrooms and most adjacent parking are now scheduled to close for renovation February 17th at 5 p.m. It's still open right now, but know that it's going to close eventually. We did, Phil mentioned it, and Katie also, about Volcano Awareness Month. I circled these two events. The one is, the Phil mentioned, is Friday, tomorrow at the Cooper Center, as well as Saturday at the Kahuku unit. Friday, tomorrow, it is a dynamic year at Kīlauea. This is Matt Patrick, geologist from HVO. He'll be doing this one. And Saturday, down at the Kahuku unit, is Trisha Nadeo. Did I say that right? Nadeo? Where the potential hazards associated with the water lake at Kīlauea Summit. Check out the shot. That's what it used to look like. If you guys are new to Kīlauea, this is what was down there before. That is Saturday, January 11th at 9:30 a.m. And if you have not subscribed to our newsletter, you can take a shot of the QR code that Dane loves that I put on the screen, or you can go over to our website at hveri.org and check it out there. All right, Dane, that's it for our community corner. I don't hear you. Audio.
I'd like to thank everybody for tuning in today. Live viewers like you, the likes, the subscriptions, the shares, all that stuff really does help get the information out there. And yeah, I'd also like to thank our partners at the Hawaii County, and specifically the Kīlauea recovery team, and as well as the support from the county council, and through the Puna Strong and Kīlauea recovery grants with the Hawaii Community Foundation in there as well, and all the support that we've gotten to do this program, as well as our digital resilience program and our new youth development program.
And Dane, I'm going to go ahead and I'm going to let you handle the super chats, but we had some donations come through on our site. I want to go ahead and throw those out there real quick. Karen with a $1,000 super chat came in. This is all last year. June with the $260 super chat. Marin with a $520 super chat. Jeremy with a $46, not super chat, I'm sorry, donation to our website. Gina with a 78. Mark, he just dropped a $20 super chat. Thank you very much to those that go over to our site at hveri.org/donate. You can donate there. We are a 501c3 community-based organization, and we appreciate all the donations that we get. Put it to good use. So yeah. Go ahead, Dane.
Yeah, so over on YouTube, we had Tiki come through with a CA $5 super chat. No comment there. And Catherine came through with a $4.99 sticker. Appreciate that. Mark followed with a $20. Obi came through. Thank you, HVERI, for all the info. US. And we then had the double take from Ed. So, well, this counts on the goal. And then he drops the $50 super chat. Do the real one, helping HVERI stay on the liquid side. Appreciate all the support there. And finally, Susan with an $5 super chat and says, love you. Appreciate all the support there. Definitely appreciate it. And we did get the website. If you were having some technical difficulties donating there, that has been fixed. And we appreciate Ed for raising that to our attention. So yeah, thanks everybody. And with that, I think we can go ahead and get into part of our special. I think start with your part. Talk about what was your experience over this little bit. I think you have a little bit prepared to show us.
Yeah, I have got a short video for you. I'll put up here. And before we start, this is taken on December 23rd, eruption morning. And if you guys know us, normally we try to get up there when it's dark, but we were busy and we got up there in the thick of it. And we were straight across near Waldron's Ledge to get this. And everybody's seen the fountains and watched what's happened for the last couple weeks. But one thing that this caught, because it was daytime, was all the fog. That's probably been one of the most significant happenings during this eruption. So I'm going to go ahead and start this off here. As well as you'll see me look for the tree. Everybody asked about where the tree was from the USGS cam. We still have not officially found it. And I zoomed back to give you an idea how far back we are at Waldron's Ledge. We're about 2 miles back. A lot of people are always interested in, are you safe? You know, we are always putting ourselves in a safe spot to do that. And that's 2+ miles back. This is an image caught from the USGS cam on the first nights when it was pointing down there. And I think we caught an owl in one of our viewers picked that up and posted that for us. Dane, what do you think, owl?
I'm trying to remember the name of what is it? The bird, the white bird that lives in the walls of the caldera.
That's not the seabird. Look how big that is.
Yeah, but I'm trying to remember the name of it though. It's going to come up in a minute.
Well, I'm going to show you again. There it is. Somebody's going to post it for us there. So we'll keep rolling here. So there's the tree and the bird, and which I'm pretty sure was the owl. Beautiful shot. That was an interesting view the first few nights with this angle on there. And then I went ahead and I put this together, and this is a 10 times speed, and up in the top right-hand corner, you can watch the plume and really get a good idea of how much fog was really being pushed out. Oh, Phil just dropped the name of it. Go ahead, Dane.
Yeah, Kō'okea.
Yep.
No, that's wrong.
There's the
Cool.
So I know the
Okay.
first couple days up there that the wind wasn't really blowing that much. You can see the plume going straight up. It was going more kau and around the island. And the last week or so, we've really got it on the lower Puna end here. Again, another
At
shot
least
from
up
the
in
back.
your part. I mean, down here, I didn't even notice hardly. There was one day I thought I noticed something, but we were spared by most of it in the lower part of Lower Puna.
So basically just stopped at my house and
Yeah.
hung a north hand turn. Lucky you. So Katie brought it up when you were talking to her, Dane. And Phil also mentioned the topography of the caldera. And this was a shot that Anna took while she was up there. And you can see the slope in here. I think I got some arrows that are going to shine. And this is just regular speed. And when you're out there, when there's two of us out there, you got 4 eyeballs looking around and you can really pick up on things. But it's not till we get home and we've shot 10 or 15 or an hour's worth of video that we really start to see the changes and the topography like this. I'm going to speed up the camera here in a second, because you can barely recognize much. So here we go at 5 times speed, and now you start picking up the little lava bergs coming down. This is one of the most fascinating parts for us to be out there filming. I know that everybody loves the fountains, but for us, we love to see all the different happenings within the caldera floor. Pulled back a little bit, and you can see over here on the right hand side right there,
There's so much lava up there too.
so much lava. Yeah. And 10 times speed, you can get an idea how much is flowing out of there.
If that thing had some slope to it or anything like that, you'd be seeing lava channels. I mean, it looks like the volume of it reminds me of Fissure 8 at some points.
Yeah.
And then it built up a 120-foot cone in 9 days or 10 days of activity.
Mm-hmm.
Pretty impressive.
And this is just another kind of zoomed out shot. Sometimes we get up there and we're filming, we're live streaming, and we know everybody wants to see just the fountains and the lava, and we slow it down and make it look just amazing up there. But I'm telling you, when you're standing up there, especially over at this lookout, which I didn't hike out to this year, Anna did, it's euphoric. It really is. The sounds, this was a loud eruption for us. Even over at Waldron's, you could hear it. So that's what I have there for our video.
Awesome. Yeah, a lot of stuff there. And what was it? How busy was it at that? Because you guys go at off hours, right? We know that during peak hours, it's jam up. Ben Hayes, we'll have some posts from the Park Service about the traffic situation up there that we're going to go through in the next segment. But during these off hours, late at night, early in the morning, how is it?
You're right. It is so much better for us to go between 1 a.m. and 7 a.m. because the experience that we had this time going up at 6:30, 7 o'clock in the morning, just an extreme amount of people, an extreme amount. And we always walk out to an area that nobody is standing at, away from everything. We have the equipment to get the shots. So we try to get away from everybody. And no matter what, there's just so many people during the day up there that it gets packed. And didn't really get the full force of it till we left the park, and out the gate, hang a right onto the highway, and at least a half a mile to a mile down of cars on the road. It was a lot of people.
Yeah, so apparently that owl, it belongs to Yvonne. She's saying that's one of my owls. So glad you captured it. I see it all the time. So barn owl, final answer.
All right.
All right. So let's go ahead and go into the next segment, which we want to highlight some of the contributors that have been posting content to social media, particularly Hawaii Tracker. So we've had 100 posts, 200 posts. I've lost count at this point. Yeah, go ahead and bring it up.
Yeah, I'm going to put that one up there. I just need to back up real quick. I was watching them earlier. There we go.
All right. So yeah, we're just going to go through and take a look at some of the videos and some of the images that people shared. Who is this one by? So we get rid of that. Michelle. I need to.
Yep, Michelle.
Let me get the
sounds of the 300-foot lava fountain, she says.
Yeah, this was early morning on the 23rd, so just before daybreak, I believe. And then being able to get, these are the first images that, outside of us capturing USGS, these were the first images from a Hawaii Tracker contributor to get posted. Then later in the morning, we got a post from you and Anna. Went up there, checked it out.
Yep, that was us that morning. That had to have been about 7 or 8 o'clock in the morning.
Right. Moving on, that evening of the 23rd, after the eruption is paused, we see here. It's nice to have everybody coming through and just being like, "Oh, it's paused now."
Right?
How do you know? Oh, I'm there.
Yeah,
I just watched it pause. But the incandescence, we could still see that glow coming out. And then another evening image over with the sun setting over Mauna Loa in the background there. So we'd like to, again, all this content is available on Hawaii Tracker. We appreciate everybody that's posted there, and all these contributors are awesome. Some great shots. And these are just a small sample of what has been posted over the course of the eruption. If you submitted something and I'm not highlighting here, apologize. There was a lot. We did have a post from Ben Hayes from the National Park Service, kind of tongue in cheek on that one. What?
Yeah.
Hold on.
Yep.
So if you enjoy waiting in traffic for hours to find parking, then make sure to visit the park between 6 p.m. and 9 p.m. You're gonna love it.
Yeah.
The original post is like, don't do that. But Ben, being Ben. All right. So yeah, we did have some short videos that were submitted just right in there of that erupting fountain. This one's on Christmas Day, so during the episode 2. Then we have another video. I really like this next video. Oh.
I mean, we captured some good audio this time as well, and we were 2 miles back, and we could catch audio.
This should have audio. I'm not surprised we're not.
You don't have the audio? You can't hear it playing?
No.
No?
So note for next time, we can't use presentations and keep audio.
Oh, yeah.
But dang, yeah, there was some great audio on that one. But just look at the waves coming off of the wall there. That's what's cool to me, is all this lava going up onto the wall and just creating this giant sheet just continuously pouring off of it, creating this weird lava fountain almost. I don't know. It's really cool to me just to watch it spray up there and then come back off of that mound.
This shot was impressive to me because they're zoomed in pretty good, and it's a good clear shot. I mean,
stable.
Yeah, it's moving around. It's not on a gimbal. It's not on a motorized gimbal. They're holding a camera and doing this. It's really good.
Pretty impressive.
Yeah.
Yeah, and also the exposure on them. That's the one thing why I don't go and take these photos anymore. It's very difficult to take photos of the lava and get your exposure correct. And if you have any comments on these things, feel free to jump in at any point. But yeah, that's one of our contributors, Lance Page. So this was, I believe he says Christmas. It's hard to know on some of these things because people will take photos and then post it the day after. But it's within, that 24-hour period roughly around Christmas. And just put it on the show out there, and we can zoom in and look at one of his shots and just the detail on that. And again, this is why I don't even try anymore. I'm not going to get that kind of balance correct. Yvonne showed she did a lot during this eruption. I think she was taking photos out 3 times a day, every day during the eruption. So her reports, awesome stuff out there. Somebody that's out on the volcano very, very frequently. So appreciate those posts, and we can just dive into one of those as well and see those 2 fountains up against the crater caldera rim.
Here's one Phil might want to chime in on right here. Unless you can break it down. What is this? Reticulite? Is that, did I say that
Reticulite.
Correctly? Reticulite?
Yeah. And another word for tephra, and really it's the very, very light, the lightest rocks that you'll find out there that are mostly air. And this rock can be easily turned into powder with just the littlest amount of force applied to it. And you'll find them right after the eruption. They can float on the wind for quite a distance as well before finally falling to the ground. So yeah, there's lots of different stuff in there. Phil, you want to hop in?
Nope.
All right.
I'm not sure how to. Oh. All right. Yeah, I was going to say that's really interesting. The reticulite, something we've heard before, requires really high fountains of lava, right? So that's just another indicator of how high the fountains were in those early phases to produce this stuff, and then blow it away. Yeah, pretty cool.
Thank you, Phil.
It's a great shot too. She's shooting the eruption, right? Zoomed out to the max, so she's over a mile and a half away there, and then she's good enough to we're gonna zoom in on this. So good job, Yvonne. She's turned into a great photographer.
Yeah. Then don't think about swimming. That's
don't.
True. And there's another national park post from Jessica Farrakane this time, just giving a heads up out there. And photos from Janice Way again, a park photographer. Warren Fentz. I met Warren originally on a media tour during the 2018 eruption, and he's been producing these types of high quality footage ever since, and long before that as well. So another professional on tracker. Just blows my mind how they're able to record this well, with this from that distance, with the conditions, with all the light and the saturations and everything. So awesome. Appreciate this continued contributions. Yvonne again showing up. And where are we at on this one? We are at December 30th, so we're progressing nicely at this point, and we're into the third phase or third episode of the eruption. And got that primary lava fountain now, but also again looking over Mauna Loa sunset. Those are some of the best shots out there, is when you got both volcanoes in sight. You can get to do some cool things with them.
Oh, there's Anna again.
Yep. Really good stuff.
She left me in the truck for this one. I didn't hike out.
Right. Not the timing wasn't great for all of us on this one.
No. There's
This was
Kim.
a very popular post on Tracker. It was one of the more popular ones out there, but devastation tailhead, and just showing some of the different photos from there. Spent 4 hours out there and generally happy with it. Just at this point, you can see how deep it is, those fountains coming up through that standing lava lake. So it's easy to see the drain back afterwards, or before it, sorry. And here you've gone again onto the 31st. I think we have one more that zooms in on that.
Yep.
Yeah, really cool stuff. Now we are on to New Year's Day, I believe. Yeah, New Year's. And this is at the evening time again. Some of the best times you can be out there is golden hour and blue hour, in the morning and the evening. But those are also the most popular times.
Yes,
generally speaking. So it's going to be, for these types of eruption, we call it the lava stadium. But the tailgate party starts long before you get there, and you're going to have to go through it essentially.
And we were really limited to only one viewing area, because from the Jagger Museum, the Kīlauea Overlook, you couldn't see the cones from up there, so everybody was going to one lookout.
Waldron's in Kaluapele. Could you see it from Kaluapele or no?
Yeah, that's where everybody was going.
Okay,
I mean, you could see from Waldron's and Volcano House, but everybody wanted that one shot. Everybody wanted to be right here with their cell phone. Where did I go? Right there. Everybody wanted to be right there. Yeah, and I don't blame them.
Carter with that one.
Yeah, Volcano House was packed, 5 people deep, as well as Waldron's. Even where we tucked in on the trail in the bushes, they found us, and we were 5 people deep at one point.
Yep. So now we're on to January 2nd, and we're still strong on the eruption, right?
Oops, sorry.
Still going. You see the different angles that people are able to get from it. It's just, trying to get that great shot, that perfect shot, especially since the last 2 eruptions, there haven't been any good shots from, at least, the photographers that were accustomed getting content from. Just the lack of access, the time of it, the inaccessibility, all of those things. So awesome to see again. Lehulu, Happy New Year. The Pele's fireworks, as we were hearing, pretty consistently throughout this eruption. Michelle, basically saying Devastation Trail is their favorite. Lots of little areas to poke out in and out and take a. But as they're saying, it seems the eruption is fading. Got to go before it dies down. And we're about at that point where it starts to turn off. We can see some of those shots from a distance. They're still a ways back there.
Yeah, they are.
This one, you can see the tropical bird that lives in the caldera wall. You see it right there, and it's, remember the distance, but it looks like it gets awful close,
right? And
then just flies right above some 2,000-degree lava flows. Just I don't know. It's pretty cool. That's pretty cool. Just a good capture. So that was from Tom. And all of these, again, are on Hawaii Tracker. They're still saved there. We just went and created a little collection of them to highlight here for you this evening. So Timothy comes through on the 3rd, and my superpower that shuts down volcanoes finally took the night off. We spent the evening being memorized by the volcano. So he was predicting that I get up there and then it turns off, which happens to a lot of people when they come to try and chase the volcano, so to speak. We see one of these late stage views of the fissure in there with the well-developed cone at this point. Warren Prince comes through again on January 4th.
There's those long exposure shots, huh?
Yeah. And it's cool how they can do that kind of stuff
Mhm.
and just balance it all. But one of the big stories, right, about this whole thing was the fog, and we were up there Tuesday after the eruption had paused, and we were kind of shocked at how much fog was accumulating, mainly because of the lack of winds. And it reminded me the sunsets of the 2018 sunsets at points where it doesn't even look like a sunset. And I couldn't capture these either. And this is really, it almost doesn't do it justice, but it's when you get the super foggy sunset, it looks otherworldly. Yeah, the final one from Josh, just after the pause, January 6th, and got some exposure to be able to get this shot over the Mana with the moon over there and the galaxy in the background. So really one of those once in a lifetime shots almost. Got to get it just right, the timing for something like that.
There's so many things going on in that shot.
Yeah.
No way. Yeah.
It's pretty cool. For it not to be a composite.
Yeah.
For it just to be, he was out there and just was able to get it. Pretty cool.
And just great job by the majority of all of the contributors to Hawaii Tracker with all their photos and videos. You know, just a basic cell phone these days really does take a great shot. So we appreciate everybody putting all their videos, all their pictures up. We see a lot of different angles and a lot of things we might not see if you didn't put it up. So thank you very much.
Yeah. All right. Well, I think that gets us through all the stuff we had for this segment. Appreciate you sitting down and going through it with me, doing a little replay, Lou.
Right. Yeah.
And I think at this point I will tag Phil back in. And thanks again, Lou, for jumping in with me.
Welcome.
Welcome back, Phil.
Hey, thanks. Yeah, that was awesome, guys. Yeah, it was great to see how accessible and visible it was this time, and how everyone was sharing all that, right? And that's really the great thing about this eruption is it very briefly tested our emergency preparedness, but afterwards became more of a show and a holiday treat for all of our residents and visitors here. So awesome to see that. Of course, with all those people comes people problems, right? You know, I saw Park posting about the lock your cars, don't leave your stuff out. There was a post that reached me across the world in international news about a kid running towards a cliff. I'm not the only one who saw that, I'm sure. But, you know, among all the other stuff of it, I also heard a rumor that at the Volcano House a few nights back, we actually had a former POTUS as well visiting. So that's how popular this actually was, and awesome that everyone got to see it here.
And if my timing is, and that timing on that, I think it might have been except for him too, because I think he showed up after it had paused.
Right. I think it was overturning and still glowing at that point in time. So there was something to see.
There was something.
By the time I came out of my travel stupor, it was too late for me. But yeah, I'm glad that POTUS got to see at least some of Pele's end game there, and you can leave all the jokes about the buttons of lava and all that, right? You know, who was it that was saying that whenever they show up, the eruption ends? Yeah, that's how I was feeling this time.
Yeah.
All good. I'm glad everyone got to, and there's plenty to share, plenty to see, of course, and in fact, too much to catch up on just one day. Right. We're already going long. We'll do it more in the future, especially if nothing else pops up between now and next week. We'll have more time to talk about all these details as well.
Yeah. And then tomorrow, we have our live stream of the Volcano Awareness Month. Hopefully, fingers crossed, everything goes off well and we're able to live stream it. If not, then we'll be doing probably video release on that. But that'd be tomorrow about the same time, right? What time does that one start?
6 p.m., I believe.
Okay, and a little later than our normal start time, an hour later than our normal start tomorrow. But yeah, we'll be hopefully bringing that to you if nothing goes wrong.
All right, if there's nothing else, we'll wrap it up for this week.
Yeah,
hello to all of our contributors, Hawaii Tracker, all you guys who have been contributing more than the ones we just shared on screen here, but lots and lots of you guys, and keeping each other informed and encouraging each other to go and experience the beauty of summit eruption when there is no danger to people. apart from the VOG, which we've heard a lot about even in the last week. So yeah, awesome to have all that. And mahalo to Lou coming on and sharing his experiences here as well, and keeping our ship pointing in the right direction, as we really had to catch up. It's been hardly any breaks, really, it seems like, in a long time. So busy year.
Yep.
And we'll look forward to be ready for the next one here, whatever may come next.
Yep.
So from a nonprofit HVERI, backstage we have Lou, mahalo Lou, Dane DuPont, I'm Philip Ong. Mahalo to our ASL interpreters, Dano and Carrie Kaufman. Aloha, everyone.